Hello and welcome to our first episode of Fun Times and Statistics. I will be your host, Rochelle Barr. Just as a reminder, this is for Northwood University, and the views expressed here are mine thanks to what's known as educational freedom. I might be quoting the wrong thing, as always. I know this is your first time watching one of my videos, lessons about the class. What I suggest you do when you are watching these is to have a notes version printed off of the PDF that is above this video so that you can follow along and write things down that I'm going to say, and or write things on your notes because sometimes we'll be doing that as well. So let's talk a little bit about business statistics. So I'm going to do an outline of what we're going to cover on the next slide, but I thought I'd talk to you a little bit about the goals of the class before we started. So this is a business statistics class, which it is a math class, but it's a little bit different from what you might be expecting. So primarily in this class, we're going to focus on learning about statistical thinking. So thinking methods, definitions, and skills that we can apply to data. So think plan, do, report. That's what we're focused on, which is very different from your standard algebra class where you focus on like algorithms and repetition and getting a right answer. And I know that might be easier to teach and to grade, but it's not something that's as applicable and flexible to the business environment. So we live in the era of big data, and there's a lot of data in the business world today. So what we want to do is we want to learn some basics on how to do some things to data so we can make some predictions and decisions about it. So that's where we're headed. And it's going to take us a while to get there. We've got a whole like 15-week journey ahead of us, or 6-week journey if you're taking this in the summer. I should have never said that. But basically what we want to do is we want to use data to make better predictions and make good decisions. So that's our goals. Let's talk about what we're going to do today. So it's going to be very basic. This is kind of like the first chapter of a book, you know, where you're going to learn all the characters and maybe a little bit about them, but not everything. So that's where we're at right now. It's a good analogy for what today is. So basically, these are the outcomes I'm going to cover in the order I'm going to cover them in as well. So we're going to learn about collection methods, some differences. So I have in here understanding similarities and differences between sampling methods. We're also going to learn what the sampling methods are, so that's important as well. But be thinking compare and contrast because some of them are similar, some of them are different, and we're going to organize them in a nice way that you maybe have never seen before, even if you've had this class before. The other thing we're going to do is we're going to talk about data type and level. These last two outcomes, you notice they're the understand. Those are the more complicated of the two. Know is very basic level of understanding. So just so you get an idea of where the more difficult parts are going to lie. One thing nice about this video is you can rewatch it anytime you want. So there's that. All right, so what is business statistics? I already gave you some hints about this, but this is a little bit more in depth. So we're going to convert data into something meaningful. So I know I just wrote information over here, but it's something that you can use to do things like, you know, describe or predict things about your, let's do sales data because that one's easy. So I've got the two types of statistical procedures we're going to do in this class. On here, we're going to do descriptive statistics, which is just describe what I have now, and I'll do a more detailed version of that in a minute, and inferential statistics, which is being able to infer or say what's next. So what we're going to focus on is how to use those two methods to gather information from our data. All right, back to what I'm going to do to my data. I'm going to either describe it, so it's going to be procedures and techniques. There's also going to be some visuals in there designed to describe how your data looks. So if I have some variables about my customers, maybe like their most recent purchase, how much they spend on average at my store, that kind of stuff, that's what I'm going to be able to describe. And then inference is really about taking the next step. It's taking what I have and what I'm able to describe and noticing commonalities that allow you to predict what's happening or infer what you notice about common things amongst my customers. So I know I'm going with sales data just because it's the easiest. There are other applications of this. So I'm assuming at some point you have purchased something online because we live in the digital era and I hate meeting people. Hence why I teach an online class. Just kidding. People aren't so bad, but okay, waiting in line sucks. There's my problem with shopping. If you purchase things online, one of the things you see really commonly nowadays is people will immediately get a recommendation for, oh, hey, most people bought this also with it. Like if you buy a TV, they're like, ooh, do you need cords? Like, do you need an HDMI cord? Do you need a 4K? Do you want to also add on an extra, such and such thing that you might want? Like when you buy an Xbox, would you like another controller? That kind of thing. They're frequently purchased items together. That's coming from an inference. Someone has looked at previous data and noticed that, hey, when people buy a TV, they need a cord. Almost 80% of them buy a cord. We should sell these as a recommendation. It's just like anytime you purchase anything on Amazon, it gives frequently purchased together packaged items. Wow, I couldn't get that out. That's an easy example of where inference is now affecting our society. Alrighty, so what kind of descriptive procedures are you going to learn in this class? We're going to learn to make charts, tables, and graphs. And those are all the visual ones. And then we're also going to learn how to do what are called numerical measures. So these are going to be more the traditional mathematical stuff because, oh boy, look at all those symbols. We're going to do a lot of those in the next chapter. So be thinking, I'm going to have visual ways of describing data, and I'm also going to have numerical ways of describing data. Like I did one earlier, I said, 80% of my customers also buy a cord. There's an example of numerical measure. I could say the average person spends over $300 on their TV. There you go. There's another numerical measure for you, just to give you an idea of what we're going to get up to. All right. So inferential procedures, we're going to spend the last probably 4 to 5 weeks of class on this. This is the last sort of end of the class. It's not the most of the class on these two. And they focus on 2 prediction types you can do: estimating, and I give you an example here, and hypothesis testing, which is about testing claims. So these are the 2 type of inferential procedures we're going to focus on. These are not the only types of inferential procedures. These are the 2 major and most frequently used ones, and they're really the most useful ones. So estimating is used when we want to make a prediction about a larger group. So notice it says the average family income of all families in the city. So I'm doing a larger group people, all of the families in the city. And we're going to see more about that later. So don't focus on these 2 too much because they are something that we will spend more time on later. And then hypothesis testing, this is, using a sample to test whether or not a claim is unreasonable or not. In this case, the claim is that the average family income exceeds $45,000 per year. So you would test that using something called a hypothesis test. All right, let's do a little example. So suppose you're looking at the following situation. A manager of Anne's fabric shop has collected data for the last 10 years on the quantity and type of each dress fabric that has been sold at the shop. Sorry, at the store. Why am I reading to you guys? She is interested in making a presentation that will illustrate these data effectively. So what I want to ask myself here is, do I think this is descriptive or inferential? So if you're watching this video, take a pause for a minute, ask yourself which one this is, and then I'm going to give you the answer. Ready? Answer coming in 3, 2, 1. That was too much of a delay. This is going to be descriptive because she's looking to present these data effectively. She's not trying to make a prediction with it. She's just trying to present what she sees so far. So I would probably do some kind of graph with this, is my guess, what she's probably up to as well. This is descriptive because she's just looking to describe it, not use it to make predictions. All right. On to our second outcome. Hey, let's talk about how to collect data. So I've got the typical data collection techniques on here. We're going to talk about some other techniques as well. I also, what was I going to say? So this is going to be an outline of each of them. So these are the ones we're going to cover: experiments, telephone surveys, written surveys, and observation or personal interviews. As you're looking at this, keep in mind when I say written surveys, we kind of include the online version as well with that, like the ones that you might do on your phone for a chance at winning a gift card and stuff like that. All right, experiments. So experiments. This doesn't work great as a visual because you can't see me. I'm like putting my fingers together weirdly like a mad scientist. Because these are the kind of things where you're going to manipulate individuals to create treatment groups. We're not going to spend so much time on experiments in this class. We do a little bit with them, but they tend to be something that's used more in statistics too, just so you know. Anyway, so this is the process of a single outcome whose result cannot be predicted with certainty. So the outcome is unknown, and it's usually something that you can repeat. And what you will do with an experiment is you'll design something that allows you to test different variations to see if they affect the outcome. What do I mean by that? Let's look at an example. So suppose you want to do the best French fry you can possible. So you separate out all your potatoes into different categories based on type, 1, 2, 3, and 4. So think like all the red potatoes together, all the yellow ones together, the brown potatoes, and I can't think of what the last one was. I somehow came up with 4 at some point. There's a description of this in your textbook. Not that I assume that you'll read it. And then blanch and time. So be thinking blanch, temperature, and time. So what time and temperature I'm cooking it at to create the best fry. So as you look at this, there's 4 options for potato category. So 3 different options for temperature and 4 different options for time. This creates 45 different options. So what you might ask yourself is which option creates the best one? Does time matter? Does temperature matter? Does potato category matter? Which of these seems to have an effect? And hopefully your experiment would allow you to see that. All right, here's the major steps to doing a telephone survey. The first thing you need to do is define the issue. Hey, what am I trying to figure out? Define your population of interest. What group do I want to know this about? And then you want to do a pretest. The reason you would do a pretest is this is kind of like a trial run to see how things go. Do I need to tweak my questions at all? And do I need to do a different number of people than I might have thought? You'll see how this works when we get into using some survey statistics to do some inference on why you might want to change some things when it comes to sample size and sampling method to make it go a little smoother. And that's why they usually do a pretest, so they don't waste money or time doing a bad survey on a large group. Here are some issues you might discover in using a telephone survey. People don't answer them a lot. And a lot of people, even if they do answer, they won't answer something if it's going to be really long. So if you've ever had to call customer service on something, occasionally you'll be asked to do a survey. They're like, it's only going to be 4 questions. That's like the motivator for you to stay on the line and do it. Yeah, so there's that. It's a little bit of a problem. These are not used as much as they used to be, but we're still going to talk about them. Yay! When you're making a survey for this, you want to make sure you use closed-ended questions, things that are short or that you can do a list for, like the example I have there. You always want to include some demographic questions. Demographics are going to be characteristics that individuals already have, not their opinion, like what their background is, how much money they make, what's their age, that kind of thing. Alrighty. Written questionnaires are slightly different from telephone surveys, as you have to be very careful with formats that they're easy to read and understand and that nobody misses any questions. They need to have some sort of statement of purpose of why this is done. Usually if they're research-based, they also have to have a statement about who to contact if they have questions about the survey. And you can have more open-ended questions with these, like asking for people to write in their opinion. And they're usually cheap, especially if you do them online. Here are the major steps for this. Notice it's almost exactly the same because it's the same. Anyway, you can allow for open-ended questions. I already said this. Here's an example of one for you. Good times. That almost looks like a test you'd have in one of your financial classes. I should pick a different example for that. Too late now! Anyway, so where you'll see this a lot is employee surveys, college courses. I don't know if you've ever taken in part of any kind of academic research where they've asked things like, oh, we tried this with your class and it was experimental. What did you think about it? That's a really typical use of this. The other place it gets used is employee satisfaction surveys, and we're actually going to do some stuff with that in this class. So fun facts, data. Some advantages and disadvantages. I mean, it's a lot like everything else. You don't want anything that's too long. It's hard to get a response rate. I don't know if you've ever received a mailed in written survey. You usually get them from your doctors. Fun facts. And they usually have a non-response rate that's a little concerning. Online ones are a little bit better. However, there are people who respond to online surveys and just fill out garbage to try to get a chance at winning things, and then it's not such good quality. All right, last type, observations and interviews. So this is where you directly observe something or you interview individuals in person. The personal interview ones is really popular when it comes to academic things, so interviewing students to see what caused them or what, in their opinion, had an effect on their success or non-success. Good times. Yep. These are both time consuming, by the way. Direct observation, typical applications of it. Yeah. I think the most frequent use of this is probably for safety observation, and just saying. Anyway. Another thing to watch out for is the Hawthorne effect. If you don't know what the Hawthorne effect is, it's where an observer, just by observing, causes the individuals that are being observed to react differently. It's just like if I give you a warning about making sure you don't cheat on a quiz, you might be a little bit more policing about your own body movements and your own eyes when you're looking around the classroom now that you've been warned, ooh, watch out for cheating, that kind of thing. So you behave differently based on whether or not you've been told you're being observed. It's kind of interesting. It's sort of a reactive effect of being observed. It changes human behavior. Anyway, and then obviously, the other things on here. Yep. And I don't think costly and time consuming are too surprising for this one, simply because time is money. Woo! Business. Personal interviews. Interviews are also really popular in academic assessments. I think I've said this already, but I'll make sure I say it again. Typically, if there's an academic program that's under review, they'll want to interview individual students to see how it's doing. Just to give a personal bent, because what the data might say might be different from what the personal experience is. All right. Interviews are better if they are structured, in case that was unclear. You don't have to have any follow-up or elaborate answers, and nobody does anything a little crazy. I would prefer, if you're going to do interview type data collection, that you do structured interviews. Unstructured interviews, usually there's no determined questions, and these are just some things to watch out for. They can be a little bit more difficult to quantify because they allow people to sort of probe and change what they're saying. Alrighty. Challenges from interviews. Interviewer bias. If the interviewer doesn't like the interviewee, this can often cause problems. Usually it's best, if you're going to do these types of things, that you do a video recording of the interview, because then you can actually have an accurate response. I know I have capturing it on there accurately as a thing. With the amount of time constraints on this, it's often not possible for you to get a large number. Alrighty. Here's a summary of everything we just did. Woohoo! Yep. This is one of those slides that you should heart and star so you don't have to go read through the others. Just saying. Anyway. The other popular type of data technique that I should have mentioned earlier, but then I think I just said and others because I couldn't remember what it was called, is focus groups. These are much more popular when it comes to doing what's called A/B testing and before and after testing when it comes to focus on product selection. So let's say that you were a marketer who's coming up with a new commercial and you wanted to see which version A or version B, was preferred. You might get together a focus group and have them watch both of them. Usually we would do multiple groups and show it in a different order, like A first in one and B first in the other, and then ask their opinion as to which commercial they liked better, and then ask them to critique them usually. So this is a very typical use of a focus group. It doesn't have to be a commercial. It could be literally any product in the world. And it even could be a product demonstration to see if it changed people's opinions. It's kind of fun. Yep. Alrighty. This is the last thing that I want to say. Usually we call this data mining. You use some pre-existing data that someone else has that you want to use. This is why companies will sell your data and information, because there's others out there who are like, oh yeah, I'll buy that and then see if I can get anything from it rather than trying to collect my own. Yeah. This is the last type that I think is really interesting. So if you own any type, or sorry, if you are a member of any type of like sales club, such as you have a Target Red Card, or maybe you have Meijer Perks or Kroger Perks, or if you're a member of any of those like special perk or group organizations where they give you discounts on sales and products, what they gather from you is your personal information, and then they associate it with all the things you've bought. This is called transactional data. And they help to use it to predict what they should keep in stock and what you might buy, which is interesting, using barcodes. This last one is a little bit of a wild one. You can also track people using radial signal devices. This is mostly used by logistic companies, which is like shipping and transferring. So if you're wanting to keep track of how efficiently your packages are traveling, this is the most common use of it. The other thing it gets used for occasionally is for traffic patterning. This is used to be how they would judge on toll roads whether or not they had enough lanes or if they needed to improve traffic flow. Fun fact. Alrighty, we're going to talk about issues in data collection. Now I'm going to divide this into two groupings basically. I'm going to talk about biases, which is not the same as personal bias, which is whether or not you are biased about something, like I like birds better than cats and dogs. You know, there's an example of a personal bias. It's my own opinion. These are not personal biases. These are going to be statistical biases. And then we're going to talk about errors and validity, which I've grouped together just because there's three of them and they're, I don't know, thoughts. Let's get it. All right, this is when this is kind of bad, but these are the types of statistical biases. When we talk about bias, this is what I mean. I don't mean anything other than these four. So the first one we're going to look at is interview bias. This is when you're doing a personal interview as your data collection, and your interviewer does things that are biased. They either repeat questions when people refuse to answer, or are not satisfied with the answer. They have a tone of voice about it, or they just say questions differently to different people, and that can cause some bias. Non-response bias is when you aren't able to collect enough data to have something useful. This can happen a lot, especially if it's an inflammatory topic. Selection bias, this is when the method you use to create your selection of data causes a bias. So I gave an example here that hopefully y'all can relate to. So suppose you want to know about increasing the university's technology fee, but you only ask the questions to the new university's esports team. So the people that are using all the technology get asked, should we have a bigger fee? And they don't care because they're using it, you know? In fact, bigger fee might mean better stuff for them. So it's not a good selection. Get what I'm saying? Anyway. Observer bias is an interesting one. It's one of those things where if you've ever had two people watch the same event and they see it differently, that's exactly what this is talking about. So if you and your friend watch a car crash and they're like, oh no, car number one was at fault, and they're like, no, it was the other guy. It was him, you know, that kind of thing. So this mostly comes up with worker safety, especially if somebody's been doing the same position for a long time. What they view as safe might not be the same as what a observer coming in from a different situation might say. So just to keep that in mind. Measurement error is when an item recorded does not match the type of data for that variable. My favorite example of this was I used to give a survey when I taught in Ohio to every first year statistics student, and on there was a question that asked, how much was your last haircut? And I had somebody write 20 to 30 minutes. How much? Price? Time. These are not the same type of measurement, hence the measurement error. So I gave another example here, but there's another fun one for you. Anyway, Sampling error I included in here, even though it's not in this chapter, just because it's another type of error, so you can watch out for it. And this is just natural variation between two samples. If I gather a sample and you gather a sample and they have completely different people in it, and we ask those same people the same question, what I get as a result might not match yours because it's a different sample. This is going to happen. Every sample looks different. All right. Validity. This is the question of, can I generalize my results internally or externally? External validity is mainly focused on, can I apply what I learn, what I've seen or observed or gained from my data to other situations? So it's applying it to the outside. Yeah. So it's just like, if I discover that, all the students at Northwood learn better when I teach them using the modified Moore method. Can I apply that outside? Well, maybe. We'll try it on a different school and see if the same thing holds. And if it does, that validates it externally. Get the idea? It's an outside source that shows the same pattern. But you have to be careful because those outside sources might not be the same. We're a primarily business-focused school. If I apply it to maybe like a public university that's not a business school, you might have different results because they are a different population. Fun fact. All right. Internal validity is where you want to make sure that your experiment is accounting for other factors inside. So we're going to talk more about internal validity when we start talking about confounding variables and how things interact. But for now, what you want to watch out for is there something else inside of my group that I'm currently interested in looking at that's causing what I'm seeing, and not something else that I didn't account for in my experiment or observation or study. Alrighty. Now on to some words. This is very definition heavy this week. I told you, we're learning all the characters before we let them play. Anyway, I've used this word a couple times, but just in case you didn't know, population is the set of all objects or individuals. It's the group of people you are interested in knowing information about. That's what it is. There's the formal version. A sample is a subset of the population. That's it. It's just a smaller group. So often if your population is something huge, like the entire United States of America, and all the people in it, getting a smaller group is much easier than dealing with the whole group. I mean, I think we have 3.28 billion at this point. That's a lot. Maybe it's million. I don't know. You know what's funny is I looked at the census just about 2 days ago, and I literally don't remember already. That's bad. Anyway, speaking of census, transitions. A census is when you want to sample the entire population. So the U.S. does a census every 7 years, and it's where you take the entire population and make them your sample. I'm literally going to try to do everybody. It's a little hairy, kind of impossible. Yeah, maybe don't do that. Here's just a visual example of the samples. So I've got a population, everybody in my market area. Maybe I'm only able to grab a small subset of that grouping. Get the idea? All the letters of the alphabet, the letters I was able to get. All right, now for another example. A student council at a large state university wants to know the student opinion on carrying firearms on campus. Oh no, inflammatory topic. They asked 200 students at the library what their opinion is. In this example, what is the population? What is the sample? So the population is always the group at large you want to know more information about. So they want to know student opinions. They want to know the opinions of all the students at the university. That's a lot of people probably, especially since it's large. And what's the sample? Oh, it's the 200 people they asked. So the sample is always smaller and more specific. The population is always broader. And usually you're not going to be able to say how big it is, what size it is. Parameters and statistics. Oh, statistics is the next slide. Oops. Good job, teacher. Parameters are always some sort of numerical descriptor of your population, and it's computed from the entire population. So I have 2 examples on here. The average yards gained per play by all NFL teams, and the proportion of university students in all of California who have more than $40,000 in student loan debt. So I've underlined the parts that are important, that are the population that I'm gathering this information from. All NFL teams, all university students. All is the big part. Everybody in that group, everyone in that population, not a sample. That's what makes these numbers here the parameters. Oof. All right. Statistics are not parameters. They are a numerical descriptor from a sample. So they're similar, and a good statistic will estimate a parameter. So here are two examples of statistics for you. The average credits taken by a sample of university students, the proportion of defective parts in a sample of all parts selected from parts made by an auto supply company. So, yeah, samples, smaller groups, more manageable, much easier to calculate. And what we'll focus on in the last couple weeks of the class is how do I use samples to estimate populations? How do I use statistics to estimate parameters? Let's talk about sampling techniques now that you know what a sample is. So there's two types we're going to look at, statistical and non-statistical. I, of course, as a statistician, mathematician person, like the statistical ones. Basically, to be a statistical sample, you have to have chance or randomness built into your selection method. Non-statistical methods don't use that. They use just different stuff, and it's got a way of unevening things. So here's an organization of the sampling techniques of what we're going to go through. Yes, there are many of them. I'm going to cover them all. It's going to be a fun time. But as you can see, there are some non-statistical ones and some statistical ones. All right. We're going to start with the non-statistical ones because let's do the worst first. A convenience or a voluntary response sample are just done at the most convenient manner a researcher can possibly do. Let's just go grab all my friends and ask them. That's basically what this looks like. It's usually the worst one you can possibly have too, simply because, well, you know, it doesn't include everybody. It's just whoever you can easily get. Just not a good plan. A judgment sample is taken by those who would most likely provide the needed information. So this is a bad technique simply because it's uninclusive and it's likely to cut out any of the, what's a good word for this? Minority groups within your population. So it's less inclusive, like I said. So a judgment sample, the one I give is pretty good. It's like asking those who provide your most frequent information. So I gave an example where the manager of the company looks at their suppliers and they want to determine satisfaction. So they just ask their 10 largest suppliers rather than asking everyone. So you can see where this might be a problem, especially if a new startup might be offering you some better incentives. Anyway. So when you're doing with a ratio sample, you want to make sure that your sample matches some existing segment of the population. So for instance, at Northwood, if I know about half of my class is upperclassmen, juniors and seniors, and half are lowerclassmen, like freshmen and sophomores, I would make sure that when I go to take a sample of my students, I have about 50-50 of each. So you're just making sure that your sample matches something that you already know. This is not necessarily a good thing, simply because it doesn't necessarily match how things currently are. So it's relying on previous information, and you might see some changes in demographics over time, and therefore, you know, that's not such a great thing. And usually it's done by judgment, not previous knowledge. Like, I think about 30% of my sales are from new accounts, so I want to make sure that my sample looks like that. Well, it's not necessarily true. Now on to the statistical samples. So remember, these are all going to include random chance in them at some point to try to make sure that everything is equaled out. So specifically, why would you want random sampling? Well, because it allows you to give every sample an equal chance of being selected. It feels nice and fair. So if I was looking at all the students in my class, everybody has an equal chance of being selected into the sample. And that evens out the possibility of bias in your sampling method. So these are all unbiased in method. Speaking of, look at their names. They have random sampling in their names. So we're going to be doing simple, stratified, systematic, and cluster. Cluster is frequently confused with stratified, so I'm trying to separate them from each other, but I'll talk about how they're similar and how they're different as we do this. So I'm going to do sampling method and then a little bit of examples about how these work. Woohoo! So simple random sample is the simplest one. Like I said, everybody has an equal chance of being selected. And then you use a random table of numbers or a number generator, or even just rolling a dice to select them. Minitab of the statistical program we will be using will do this for you in one step. It's pretty easy. So good times. A stratified random sample divides your population into subgroups called strata. So be thinking stratocumulus clouds, like the little lumpy clouds in the sky, like the little lumps are your groups, and you're going to rain down individuals from your groups. Strata usually are things that your individuals already have as a behavior. So like their gender, their income level, their marital status, their age. These are characteristics they already possess. You use those to make groups, and then you randomly select from each of those groups. So you have this random element as well. We have this little graphic below of that. So you've got 4 little strata, and you select 3 people from each strata, and those together make your groups. Good times. Or sorry, your sample. So here's a more relatable example for sampling. So suppose you wanted to know some interesting things about cash holding financial institutions. So you separate them into large, medium, and small. So little itty bitty like local only banks. And then here's like JP Morgan, Chase. Wait, Chase and JP Morgan separated. So JP Morgan. No, wait, is that a cash holding one? I am not a finance person. Anyway, then you select a bunch from each of them so that you get a representation from each, rather than trying to select all of them. That just sounds scary. All right, some advantages to stratified is it creates homogeneous, so that means equal in each of your stratum, so that you get like some equality amongst all of your groups. It sort of smooths things out, like homogeneous. Sounds like a smooth word, right? Except for when I say it. Anyway. It also allows you to create smaller samples that have representation of different groupings in your population, and usually that's cheaper. Systematic sampling. Now, the definition given here I've taken from your textbook, but that's not the only way to do a systematic sample. So here you would pick a sample size, you divide your bigger group of samples into that sample size, and select so many from your sample. That just seems insanity. So with this one, it's kind of like, I want, 100 people, so I'm going to take this list of 1,000 and divide it up into like every 10th person, so I get 100. That's, yeah. Here's 2 examples of how you might use systematic sampling. You could pull out the phone book and then call every 10th number in it. Now, with that version, it's a little bit not appropriate or non-random, because if I repeated it, pulling out the phone book and it calling every 10th person again, I would get the same sample both times. That does not create a new sample, therefore it's not very random. Another way you can do systematic sampling is you could go ask every 5th person who comes into the library whatever question you were interested in. And so that one would be random, because if I repeated it on a different day, it wouldn't be the same people coming at the same time. Yay. Cluster sampling. So with clusters, you also have groups in your population, and then you randomly select from those groups. So for instance, if I took my class and separated it into freshman, sophomore, junior, senior, and I randomly selected all the juniors, that would be a cluster sample, because I've grabbed one whole group. Usually people will pick multiple groups with this to sort of create a balance in the clusters. So maybe if I picked all the juniors and all the freshmen, but the point is I'm selecting everyone in that cluster, not individuals randomly from the cluster, which makes it different from stratified. Woohoo! So here's an example of a cluster sample. So this is my Amazon warehouse example. So suppose you have a bunch of aisles in your warehouse, and each has bins, and each has stacks, and each of those stacks has bins. There's so many of these, and each of your bins has stuff in them. If you randomly select bins, you're grabbing whole groups, and that will create clusters. That was the short version of this example. Feel free to read the whole thing. It's a lot. All right. So here's a little bit of a summary for you. Hey, I have a population. I can grab many samples from it in many different ways. There are 2 different types of techniques. There are the non-randoms and the randoms. We would prefer to use the randoms simply because those will be statistical. The non-random ones will not be statistical. But sometimes you have no choice. Now let's talk about our last topic, types of data and data levels. And then we're going to talk about how to combine those 2 ideas. This is going to be one of the most important things I teach you, so listen up, Buttercup. The first thing we're going to talk about is types. There are quantitative and qualitative. So when you hear the word quant, hopefully you're thinking quantity, as in something that feels like it's numerical, but specifically this is stuff that has to have a way of measuring it. So it not only has to be a number, but it needs to have units. So for instance, things like your zip code is numerical, but it does not have units, so therefore it is not quantitative data. But how tall you are, like 5'4", is, notice I said feet and inches, so it has units and therefore it is numerical. There are two different types of quantitative variables or quantitative data. There is discrete, things you can count. Discrete means to cut, so you can cut it into pieces. Like I cut my cake into 7 pieces and therefore I can feed 7 children. I don't know where this is going. Also, 7 is a weird way to cut something. Anyway, and then you have continuous stuff. This is stuff that the results, there's an infinite number of possibilities. We generally treat things that where we don't know the outcome, but it could be anything like that. Your height is an example of this, even though you feel like you round up to a certain number of inches. If you didn't round it and did it as like fractions, there's an infinite number of ways it could go. So we would treat that as continuous. All right. And then qualitative is basically anything that isn't quantitative. So anything that doesn't have a measurement scale to it. So like your marital status or your eye color. And then within those non-measurement items, you can have a scaling to them or an order. So examples of this are things like ranks and satisfaction level. So if you are, what's a good example of this? We know that satisfied is better than dissatisfied. So a satisfaction level usually is, we'll do very satisfied, satisfied, neutral, dissatisfied, very dissatisfied. We know that the 2 satisfied groups are much better than somebody saying dissatisfied. So it has a natural order to it because I know who's better or who's greater. That's what an order feels like. Things that don't have order are things like, oh, what's your favorite pet? What's your eye color? What's your marital status? Because believe it or not, when your mom tells you you need to get married, being single is the same as being married when it comes to order. Ha 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 ha. That was bad. Moving on. All right, let's talk about how level of measurements compare. So basically the higher level ones are the most complicated and have the most information and things we're going to be able to do the most to. So those are ratio and interval we're talking about next. Then below that's ordinal because it's got some way of comparing stuff. I know who's greater, I know who's less, I know when they're the same. And then lastly is nominal data, which is the stuff that has no order. It's just a big old pile of groups. Nominal data is the lowest and the most basic, and the things we can do the fewest to. And that's why it's considered the lowest level, unfortunately. Alrighty, let's talk about the difference between interval and ratio. And these are kind of interesting. So interval is data that has a comparison level to it and a measurement. So I can tell who's bigger, who's smaller, and who's equal. So it's got that ordinal feel to it, but it has measurement to it. It has some way of measuring it. Therefore, it's stuff that, like, it's quantitative. These are both quantitative. Ratio is similar, except for it has what we call a true zero. So if you think back in the day, back before they had a definition of what the number 0 was, and when we first started counting, we only started talking about items or numbers and counting in terms of things that we had, like I have 4 sheep, you know? If you had 0 sheep, you wouldn't say you had 0 sheep. You'd just say, I don't have any. You'd be like, you wouldn't talk about 0. And that became a big distinction in understanding things when there was nothing and nothing had meaning. So ratio data actually has what we call a true 0, in which 0 means I have nothing. So objects that weigh nothing are 0 in weight. Or I have no bananas, therefore I have 0 of them. Now, interval things don't have to have a true 0. So the example I give for this is temperature, because both Fahrenheit and Celsius have a 0-degree measurement, but that doesn't mean you have 0 temperature. And that's the difference, because when you're 0 in one, you're not 0 in the other, and being 0 temperature doesn't mean there is none temperature in the room. It just means it's really cold. Yeah, right? Anyway, the way I keep these straight in my head is ratio has a 0 in it, so it's the one that has a true 0, because it's got the O, yo. Yep. All right, here's some examples of nominal data for you, stuff that has no order. Your student ID number, yes, it's a number, but it has no units, therefore it is nominal because it is qualitative. Gender, yes, no gender is better than the other. Marital status, favorite color, yay, blue or whatever is your favorite, I don't know. Others, I'm sure you can think of others. There's a lot of places I wrote other question mark on here. Yuck. Anyway, ordinal data, remember these are things that I can order. Undergraduate versus graduates. Graduates are considered greater because they have more degrees. You can have a way of telling one from the other. Here's something that's incredibly important. Age group. So age itself is quantitative because it has a unit of measure. Years. Please, if your baby is 36 months old, call it a 3-year-old. Anyway, personal preferences. I'm not going to go on that diatribe because that's insanity. However, if you group those ages, so I've grouped them into under 18, 18 to 30, 31 to 60, and over 60, these groupings, and I've labeled them 1, 2, 3, and 4, so group 1, group 2, group 3, group 4, this forces it to be ordinal. So I've created these groups, and those groups no longer possess a unit to them, which is, you're losing a little bit of information there. So just keep that in mind. If you group it, you're going down one level. Anyway, and then satisfaction level, which I've already talked about. All right, I got a little boring with my examples for interval just because I use the same one, but here are some examples of ratio level data. Ratio level data is usually what most people will think of when they think of gathering data, things with units, like how much you make a year, what's your miles per gallon of your car, hours per minute. Actually, that doesn't make any sense. Time divided by time. You get the idea. There's tons of these. Ratio level is probably the more popular one to record because recording numbers seems more natural for people. And this is a math class. But don't forget, the other ones are important too. All right. The other way we can classify data is by timing. This one's a little unusual and maybe more useful to some of you than others. There's 2 types of ways we can record data via time, and those are the time series and cross-sectional types of data. This more is used when it comes to organizing data, just so you know. Time series is when you look at the same type of data over multiple units of time, and then cross-sectional is when you look at it over 1 unit of time. So one of the ways that I keep these straight in my head is notice time series plural, so it goes over many times, and then cross-sectional is not because it only uses 1. Let me show you a picture that'll help you with this a little bit. Bam. So here's a table of data. And I've got some different cities and some different years. If I just used 1 column of this, that would be cross-sectional data because it's just 1 time. If I used 1 row, that would be time series data because it uses many years, much times, 4 times, not much times. That was not good English. If I use the entire table, that would be time series as well because it involves multiple times. Get the idea? That's great when you can't answer me. So how do we categorize data? First thing you want to do is identify each factor. So the first thing I ask myself is, what are my variables? Next, we usually do time. I know I did that towards the end, but you know, I had to fit it somewhere. Then I ask myself, when I look at these different variables and factors, are they quantitative or qualitative? And then I ask myself, what level of measure might they have? Let's look at an example of this. So I've organized this for you, and I've got Excel data sheet here. We're going to mainly use Minitab, but just so you get the idea. This is going to be cross-sectional data simply because it's got no time unit to it, so it has to be all at one time since they didn't include any years. The next thing I ask myself are, what are my variables? So I've got college name, state, public or private. This is clearly going to be a indicator, so it's either 1 or 2. So this doesn't have units. That's good to know. There's SAT score, verbal, SAT. Well, that's math. Oops. And then applications received, applications accepted, new students enrolled, and number of full-time undergraduates, number of part-time undergraduates. So as I look at all these, I've got some variables, and I've got them arranged in a specific way. These first 3 are qualitative because when I look at the results, they're words. And even though this is a number, it doesn't have units to it. It doesn't mean anything. It's not points like it is for SAT and ACT, and people like it is for these guys. And this 1 or 2 is just indicating, is this a private institution or a public one? Now, as you look at this, be careful. All of these are going to be on the nominal level because Just because this is numerical and it's ones and twos, 2 is not greater than 1. There's not one way you can say a private or public is bigger than the other. You might look at college name and say, oh, well, it has an alphabetical order, but that order doesn't have any meaning. So, of course, that's kind of silly. And then you might also say, well, some of these schools are bigger than others. And again, you're just looking at that variable, not two of them combined together. The variable college name has no natural order to it in which you can compare these. Same thing with states. Just because one's bigger than the other doesn't mean that you have a natural ordering where you can compare them. You have to look at also how big is that state. So just keep that in mind. The remainder of these are quantitative, and you have both ratio level data, places where 0 means something, and interval data, places where there is no meaningful 0. So for instance, I would consider full-time undergraduates 0 being meaningful because that means I have no full-time students. These would be colleges that are part-time only and probably are likely only going to be community colleges. So it has some meaning to it. Alrighty. Bam. Here's a little summary of how you should approach this. So this is exactly what I just did. Is it time series or cross-sectional? Remember, they can be either type of data present in both, and then levels of data. And I've got these arranged in their level of complicatedness as well. So this is the least complicated all the way up to the most complicated, or most information all the way down to least information when it comes to the data levels. Yay, measurement.